All right, so this section is going to cover graphing linear inequalities. So they're going to look like lines in slope-intercept form, except instead of an equal sign, we have a greater than or less than symbol, or greater than or less than with the equal sign underneath. These will guide you through how to do that. So we're looking for solutions of an inequality that make the system true. Unlike a line, if I had, let's say I had y equals, I don't know, I'm just going to make up a line here, where I have a line on a graph. The solutions to a line are anything that fall on that line, right? So any point that falls on here is made up of an x and a y coordinate that makes it true. Inequalities are going to be a range of things. So it could be the dots on the line, but it's either going to be points above, like everything in space, or points below as well. And that's going to make sense when we do a couple examples. All right, so these step-by-step guides will guide you through how to solve or to graph these linear inequalities. So step one is make sure that they're in slope-intercept form. Slope-intercept form is y equals mx plus b, where m is our slope and b is our y-intercept. When dealing with inequalities, remember you have to flip the sign if you multiply or divide by a negative number. So if it's not in slope-intercept form, just be aware of that. You're going to have to solve for y. Then you're going to graph known points using the skills learned in the previous unit. So we're going to start by plotting the y-intercept, which would be the b, and then use the slope to get the next point where you go up or over, depending on whether it's positive or negative. All right, once we do that, we're going to plot at least 2 points. Then you're going to determine whether it's going to be a solid or a dotted line. So a dotted line will not have the line underneath. It will be solid if it does, if it's an or equal to. The reason we put it as dotted because points that are on a dotted line mean that it would be a solution to a line, but not that inequality. It could be everything but that. Whereas if it's an or equal to, it would include the points on that line. Once you graph it, read the y variable first. So in this case, like y is greater than. And greater than is going to tell us we shade above the line. And if it reads as less than, we shade below the line. I'm not sure if there's a few examples here, not in the notes, but if the line is vertical or horizontal, greater than you shade to the right, less than you shade to the left. But again, if it's horizontal, above for greater than, below for less than. So let's go ahead and take a look at one of the examples, or both of these examples. All right, sorry for these grids, but they're lines are a little bit shady, but we can still get it. Okay, so we need to graph this line as if it's y equals 3x plus 1. So we always start with b, right? Y equals mx plus b. So we always start with the last number, which would, in this case would be positive 1. So I'm going to put a dot there. All right. Then I do the slope. This is 3 and a 1. So up 3 because it's positive, to the right 1. So I can go up 3, 1, 2, 3, to the right 1. And I put another dot there. You can keep going if you want. But remember, you can also switch it up. So you can go down 3, 1, 2, 3 to the left 1. Okay, so we have our dots. So that's basically, let's look back at our notes, is going through step 2, right? We just graph it. It was already in slope-intercept form, so we graphed it. Now we have to determine whether it is a solid or a dotted line. Since there is no line underneath, meaning or equal to, it is going to be a dotted line. So you're just going to write dash marks to show that it's dotted. Every once in a while you'll draw a solid line and you'll be done with it and be like, oh, I meant to put it dotted. Rather than erasing, just put like lines through it so I know that it's dotted. If you forget it and you notice it later. Okay, once we have the line actually graphed, now we have to shade to one side or the other. All right, again, we're going to read the y variable first. So this says y is greater than. Remember, anytime you have y or a variable, if you're reading left to right, greater than, it's opening up to it. This would be y is less than. It would be pointing to it, right? I always remember, it opens to the bigger end. So as you read it from left to right, this will be y is greater than, y is greater than. Greater means we shade above the line. So you got to visually imagine which side is above the line, and that would be to this side to the left. So you're just going to kind of scribble in this side to the left right here. So this is representing all the points that are solutions to this line. So if I picked a point at random, let's say I picked this one right here. This is -1, +9. That falls in that shaded region, so that would be considered a solution to this inequality. But when we solve for these inequalities, we represent it as a graph. You can also type this into Desmos to check your solution, and it would come up that way as well. Okay, let's look at this example. For this one, it's not in slope-intercept form, so we have to do a little bit of math first, so I'm going to run you through that. We have to solve for y, so we would subtract 2x from both sides. I'm going to work my work up here. So -3y is greater than or equal to -2x plus 6. Now I have to divide everything by a -3. So this would give me y, and because I divided by a negative, I have to flip that sign. So less than or equal to, negative divided by a negative is a positive, so you can leave it as -2 over -3, or you can call it just 2 over 3x. Positive 6 divided by -3 is -2. So now when I graph this line, I'm looking at this now. This is what I need to be able to graph it. I am starting at -2, so I start at my origin, I go down 2, and I put a dot there. Then I do my slope. I go up 2 to the right 3. So up 2 to the right 3, and I put another dot. I can keep going, or I can just leave it. You don't need to keep going. So now I have to determine what type of line. Is it solid or is it dotted? Because it's or equal to, this is going to be a solid line, so I'm going to draw a solid line through it with arrows going, showing it's going on forever and ever to infinity and beyond, I guess. Anyway, corny joke there. So now I have to determine which side I am going to shade. Because this says y is less than, I have to shade below this line, so I'm shading everything down here, and that will represent everything that is less than. All these points picked in space would be solutions to that. So if I said, hey, is 0, 0, for example, a solution to this line? 0, 0 is here. It is not in the shaded region, so I would say no, it's not. All right. Part 2 of these notes would be how we write a linear inequality if given the shaded lines. So we're going to talk about that right now. So if I give you the graph, can you write the equation or the inequality, I mean? These are the steps that take you through that. So you identify the slope, so you can either count or you can use your slope formula given 2 points. Then you have to identify your b. Once you do that, you can pretty much write your inequality. And then you have to figure out what the symbol is going to look like. I put step 3 here is basically writing the form y equals mx plus b. So just put a space where the equal sign should go so that we can fill in our inequality symbol based on what the graph says. So then we replace our equal sign with the inequality symbols, and then we note it, whether it's equal to or not based on whether it's a solid or a dotted line. I guess I should close off that parenthesis. Okay, so let's take a look at these 2 examples. So I have to figure out my m and my b. My m being my slope, my b being my y-intercept. So if you want to just count the slope, you can see here I went up 1 to the right, 1, 2, 3, 4. So my m is up 1 to the right 4. So my m is 1/4. I could also use my y minus y over x minus x. If I did 3 minus 2 over 4 minus 0, 3 minus 2 is 1, 4 minus 0 is 4, so I get the same slope, so whichever one you want to use. All right, we can also now look at where is our y-intercept. Well, here's our origin, our y-intercept as 2, so my b equals 2. Now I can write the equation. I would normally put an equals there, but I'm going to put something into this space from an inequality symbol. So think of it as y equals and then 1 over 4x plus 2. All right, I'm going to get rid of this so you can see now what this is going to look like. So now I have to put my inequality symbol. This is shaded below. Below means less than. So I'm going to point to the y. Opening up to the y would mean y is bigger, but since it's going below, I'm going to point to it. Now my final step is this a solid or a dotted line? Since it is a solid line, I have to add the or equal to sign underneath, and that's how you write the inequality for that line. All right, let's take a look at this one. So I have to figure out my slope and my y-intercept. Y-intercept's pretty easy, right? I can see it right here. I go down 2, and it even tells you 0, -2. So my y-intercept is -2. Now I have to figure out my slope. I could use the slope formula, or I can just count my rise over run. In this case, I go down 1, so that's -1 on the top. And then I go to the right, 1, 2, 3. So that would be +3 on the bottom. That's my slope. My equation, y something, -1/3 x minus 2. Now note that the shading is above the line. So that means y is going to be greater. This is going to indicate everything greater than this line. So I'm going to open that up to my y. And then you can see that it's a dotted line, so I do not have to put the line underneath. So I'm done with that. That would be my final answer for writing the equation of that line.